Let's look at the following scenario. We have an angle with a measure of 0.9 radians swept out from the 3 o'clock position. The vertex of the angle is at the origin of these axes. And we have a circle with an unknown radius centered at the vertex of the angle. And we have this point 1.55, comma y. That's the location of the terminal point. And so y represents the vertical component of that terminal point. And we know the x-coordinate of it. And so we want to know the value of y. That's what we want to determine here. So at first, y represents a vertical distance, and so you'll probably feel tempted to say that since sine of our angle measure gives us a vertical distance, we'll want to use the sine function. And so it's certainly true that that vertical distance is sine of 0.9 radius lengths. However, we don't know the radius of this circle. And so we can't actually determine the value of y, or like the y-coordinate, because we don't know the radius length. And therefore, the sine function just doesn't quite do enough work for us. So to handle this, we need to bring in the tangent function. We actually know that this horizontal distance right here, we know that that is right there. That's like a change in x. We can think of that as 1.55 because that's the x-coordinate of that terminal point. And therefore, we have a change in x of 1.55. In this case, since we're changing away from x equals 0, that's delta x and x are the same value. And what we really want to know is the value of delta y over here. Because delta y will be equal to y since we're starting at y equals 0. And so somehow we need to relate delta y and delta x. Notice that this terminal ray, it's part of a line segment, so it has a slope or a constant rate of change of y with respect to x. And so if we knew the slope of this terminal ray, let's call that m for now. M represents the slope of that thing. The slope would relate the change in y to the change in x. So it would tell us, the slope tells us that delta y is going to be m times as large as delta x. And in this case, we know the value of delta x, and so if we only knew the slope of that terminal ray, we could determine the value of delta y based on this delta x value. However, the tangent function gives us the slope of the terminal ray given an angle measure swept out from the 3 o'clock position, and therefore the slope of this thing is actually tangent of 0.9 radians. Therefore, that change in y is going to be equal to tangent of 0.9. So tangent of 0.9 gives us the slope, and then the change in x was 1.55, and therefore tangent of 0.9 times 1.55 gives us that change in y, and that has the value of about approximately 1.95. So that blue vector has a length of about 1.95, which tells us the value of y is about, it's approximately 1.95. That just came from this expression here, so that expression right there is the exact value of that y coordinate.